We will now proceed to melt the lauric acid and benzoic acid mixture. This will have a green label. Be sure to record the mass for both the lauric acid and the benzoic acid. The mass for the lauric acid does not need to be the same mass that was on the original test tube. Pure substances melt at the same temperature regardless of the mass. It is only the lauric acid in this test tube whose mass matters. Once your mixture is completely melted, it is important to stir thoroughly. We want to make sure that the concentration of benzoic acid and lauric acid is the same throughout. If this is the first time that this mixture has been heated, there is a decent chance that the benzoic acid is not spread evenly throughout the mixture. Once this is stirred, remember it will take about 45 seconds for the thermometer or temperature probe to equilibrate to the temperature of the liquid. You will need to immerse the test tube into the cold or room temperature water bath and start the data collection. All the while, continue stirring. To find the melting point for the mixture, I'm going to need to find the intersection of the tangents of two areas of the graph. This first part here, there's a tiny blip. This occurred when I stopped stirring for a minute, and that is why, or for a few seconds, that is why it is important to continue stirring while you are collecting your data. I'm going to just use the first part of this graph in order to find my melting point. I've now highlighted two regions of the graph, but the initial sloping area here and the flatter region here. Remember that I want to find the point where these two intersect. So I'm going to need to click on this point here. Recall that unless I've hit the interpolate toggle button, it will only show me the data point that was actually collected at that time. So I'm going to need to go to the corner and toggle on the interpolate button. Now I can see that these two data points are very close together. I'm going to try and adjust them just a little bit to see if I can get them a little bit closer. So this looks like the temperature that we should use for our melting point of the mixture is 39.2 degrees Celsius. You may wonder why I'm not using all of the decimal places. If you look in the other corner, you will see that the temperature that we are collecting only has one decimal place. And this is the extent to which we have accuracy or precision in our collection methods. So therefore, when we are collecting our data and determining the melting point, we should only collect it as far as this point. This is okay because remember that our freezing point constant only has two significant figures, and so having three significant figures on our temperature will not affect our results.